Today we're going to be completing notes number 6 on what are called literal equations. So something that you might be familiar with is a formula. So a formula is just an equation where variables are used to describe a relationship. So examples of some formulas you may be familiar with: area equals 1/2 base times height. Okay, the area for a triangle. Okay, that's an example of a formula. There's a formula to convert from Celsius to Fahrenheit, where I have Fahrenheit equals 9/5 Celsius plus 32. Okay, so a formula, we have these variables and they have a relationship. Literal equations, formulas would be an example of a literal equation. So a literal equation is an equation that consists of mostly letters or mostly variables. So meaning that now instead of just having x or just having a single variable that we're isolating, now there are several variables. Each part of the formula literally represents an important part of the whole relationship being represented. Okay, so that's our definition of a literal equation. Now, what we're going to be doing is solving for a specific variable, one that's we're asked to solve for a specific variable in this formula or literal equation. And really the idea here is to transition from just wanting to solve from x to be able to reorganize any equation or any formula to isolate a specific variable using our inverse operations. Okay, so it's still all about inverse operations. So even though I'm not going to get a value here, so up until now we were getting a value, we were solving for a variable and we're saying, oh, x equals 5 or x equals 2, whatever it may have been. Now we're just taking a formula and we're rearranging it, so instead of having one variable isolated, we've isolated a different one, which can be helpful when we're trying to solve for a specific part or a specific piece of that relationship. So, for example, here's an equation, area equals length times width, and we want to solve for W, okay, which means we want to isolate this part of that formula. And to do so, it's about inverse operations. So to isolate W, to get W by itself, right now, W is being multiplied by L. And so the inverse of multiplying would be to divide. And remember, whatever I do to one side of the equation, I got to do to the other. If I divide by L, now I have W equals A over L, and that's it. Okay, I've rearranged that equation so that instead of having A equals, it now says W equals. Okay, now let's look at number 3. So here's our equation where I could input Celsius and get out a Fahrenheit value. And this is asking me to solve for C. So rewrite it that instead of F equals, it'll be C equals. So there's C. To isolate C, first we need to subtract 32 from both sides. So just like if we're solving for a single variable, we're solving an equation. That's going to give me F subtract 32 equals 9/5 C. Now, to get C by itself, here we have a fraction in front of a variable. So to undo that, we will multiply by the reciprocal of that fraction. That would cancel this off. 5 divided by 5 is 1. 9 divided by 9 is 1. And it leaves me with C equals, I'm just flipping my equation around. Okay, so now C is over here. Now with this, it's 5/9 times this entire side. So I'm gonna write it like this. You could, I guess, individually multiply them, but you want to remember that if I have more than one term over here, it's not just going to be 5/9 F, it's going to be 5/9 was multiplied by F minus 32. And here's my rewritten formula where I've solved for C, or I isolated C instead of initially having what it was where F was isolated. volume equation, 1/3 base times height, or area of the base times the height, we want to solve for our capital B here, area of the base. And so I can start a few different ways here. So I'm multiplying by 1/3 and multiplying by h, so they kind of are the same priority in terms of solving. What I'm going to do is first, let me rewrite this. I'm going to get rid of the fraction first. Now remember, when we were clearing fractions, we could say, well, I'm just going to multiply everything by 3. And so if I multiply v by 3, now I have 3v. And if I multiply 1/3 times 3, they're just going to cancel and leave me with bh. Now, inverse of multiplying by h would be to divide by h. And I get b equals 3v over h. So a few different ways you could have thought about that. I could have thought, well, b is being multiplied by both 1/3 and h, so I can divide by 1/3 and h. But dividing by 1/3 is a little bit funky. Like I wouldn't leave it as dividing and then a fraction in the denominator, which is why I, on problems like this, tend to deal with the fraction first by multiplying by the reciprocal or clearing fractions, however you want to think about it in that case. And then I deal with the other stuff that's being multiplied there. On 7, it asks me to isolate for b, and then it gives a follow-up question. So it's saying isolate for b and then find what b would be if p is 12, a is 3, and c is 5. So first, I'm going to isolate b by subtracting a from both sides, and then subtracting c from both sides. So I know b equals p, subtract a, subtract c. And this kind of demonstrates why we would even want to do this, which is now it's asking me to find b, which will be a lot faster with it already set up as b equals. So to find b, if I know p is 12 and a is 3 and c is 5, I can just substitute in, and again, it's already set up to give me what b is equivalent to. So now I have, let's see, 12 subtract 3 brings me to 9, subtract 5 gives me 4. Okay, so now what I'm going to ask you to do is I'm going to ask you to pause the video and try to rewrite the equations on the left-hand side. And then I'll show my work for the first 3, and then on the last one, I'll kind of wait to do the last little part with you together. But now would be a good time for you to pause, try this skill on your own, and then start the video and see how you did. Okay, so our first example on the left-hand side asks us to solve for L. So to solve for L, I subtracted the 2w from both sides, and then it was 2 times L, so the inverse of multiplying by 2 is to divide by 2. And we land here. And you can also like break this apart. So I could have also written this as L equals P over 2, or 1/2 P minus 2 over 2 is just 1 W. So I can also go through and like divide here and divide here. So if you have something that looks like this, that's fine too, as long as that both of these terms were divided by 2. Our second equation is a little distance, rate, time, asks us to solve for t, which the inverse of multiplying by r would be to divide by r. So we get t equals d divided by r. And solve for y on 6. So again, on this equation, really what we will eventually want to do, because this is actually a little y equals mx plus b, we're going to use these when we graph, is we could have also written this as -3/4 x plus 28/4 is 7. Okay, so either version of this for right now is fine. Eventually, that's really nice to get here, okay, because this is much more usable and for us next unit. Last one, solve for h. And so first I dealt with that fraction by multiplying. I multiplied everything by 2, which gave me 2a equals bh. And then to get h by itself, I divided by b, which lands me here. And again, it's a lot easier now to find h, given the other values, since I've rearranged my equation to already be what h is equal to. So h equals 2a over 8. I can do, so 2 times 64 is going to give me 128 divided by 8. I'm going to do a little division over to the side. So 8 goes into 12 once, gives me 48. 8 goes into 48 6 times, goes in evenly. So H equals 16. Okay. So you'll get some practice, some more practice with the literal equations on homework tonight. But again, the biggest thing that will help you as you work through these is remembering it's still all about inverse operations, and it's still as if what we were doing when we were solving equations, except now we're not going to get like x equals a number. We're going to get a variable equals and then some sort of formula on the other side.